Hello everyone. Here we have a project that demonstrates how communication happens between multiple clients at the same time using sockets and multi-threading. My name is Kani and I'm going to give a continuity to a presentation that was given by my colleagues. They showed how uh, server client system communication happens in theory, and I will be giving and explaining the structure of the system and how the communication happens. And finally, I will give a live demonstration of the program in action. So, going to the architecture. Here, the system consists in two main scripts, the Python server and the client server. First, the server is responsible for accepting new connection and broadcasting all the messages connected to the clients. And the client connects to the server and sends the messages and receives updated from other clients. Let's take a quick look to the server Pi code. In server Pi, the server first creates a socket that beams into a host and a port and start listening for incoming connection. Each time a client connects to a new thread, it started to handle a specific client. This allowed the server to manage the multiple clients at once without freezing or unblocking. That's why we have this here that guarantee the safe access to all the list of the clients. In client Pi, we will see that the client connects to the same host and port and waits for the message from the server that can also send message back. This iteration continuously create a real-time communication between all the connected servers. Now let's take a look to the main part of this code, the broadcast function and the handle function. These two are the brain of the project. Here is where all the communication happens. The key idea between the broadcasting is when a client sends a message to the server, it receives it and call it broadcast function. This function loops through all the list of the connected um, loops and send a message to each one of them. As a result, all the client instantly receive the message. That's how broadcast works. At the same time, we have multi-threading that ensure that the clients run in its own thread. This means that multiple clients can send message and receive message simultaneously without interrupting with each other. Without multi-threading, the server would have to wait for one client to finish before handling the next one. But with it, everything happens in parallel. Here we can see that we have the message sent to the clients, and here it allows the clients to talk between themselves. And here it shows what happens when the client disconnect from the server. You see that uh, it gives a reply. A client is disconnected and a client has left the server. Now I will show you how the system works in real time. I will start by running the server terminal in the window. As you can see, it is listed in the local host and port. Next, I'll open two client windows and connect them to the server. Each client successfully will connect and confirm to the other server. First, we will run the wait. Okay, so the two servers are now connected. The client in this side, and in the other side, we have the server. I will open this screen entirely so we can see. Okay, here, what we are going to see is that when I send a message from client 1, it immediately has to appear in the client 2 and vice versa. The server also logs all the incoming message in the same in real time. For example, once I click enter, the message already sent to the client. Here is the reply. Hi, I am the server that I write it before from the server. And here I will give a reply as the client. Hi, I am the client. And here we have a message from the client saying, Hi, I am the client. This shows that the broadcasting mechanism and the multi-thread process are both working perfectly and smoothly. The system can handle multiple simultaneous clients without errors or delays. So, in conclusion, this project successfully demonstrates a basic yet powerful example of a network communication using Python, sockets, and thread techniques. The server efficiently handles multiple clients and connection, and the broadcasting function ensures that all the server receive updated instantly. This same logic can be applied to the real-world applications such as chat platforms, multiplayer games, and notification system, for example. I'm going to send the last message, and it will be received by the server. So this was all for our group, and thank you for watching.